Hello everyone. So let's understand the scheduler concept with the help of this state transition diagram. Scheduler. So from new to ready state, we have a scheduler called long-term scheduler. Long-term scheduler. And long-term scheduler basically decides the degree of multi-programming. Okay. So how many processes will present at max in the ready state will be decided by the long-term scheduler. Okay, if there are, let's say, maximum 100 process can hold by the ready state, then the degree of multi-programming is 100. Okay, and when a process is present in the ready state, from ready to run or run to ready state is handled by a scheduler called short-term scheduler. Short-term scheduler. Short-term scheduler is also abbreviated as STS. So short-term scheduler basically dispatch or move the process from ready to run state or from run to ready state. So how it will pick those processes and move to the run state is decided by various CPU scheduling algorithms. So generally CPU will pick some processes based on the algorithms. If the algorithm, let's say, first in first out, then CPU will pick the process which arrives first. And if the algorithm, let's say, shortest job first, then the CPU will pick the process based on their CPU time, okay, or burst time. So various CPU scheduling algorithms comes into the picture when we handle the short-term scheduler. So short-term scheduler, the main responsibility of short-term scheduler is to dispatch or move the process from ready to run state or run to ready state. Dispatching the process from ready to run state or run to ready state is also called context switching. It is also called as context switching. Okay, and context switching is done by a dispatcher. So dispatcher is responsible for context switching. Okay, and the last scheduler, basically there are three types of scheduler available in process states transition diagram. One is long-term scheduler. Long-term scheduler decides the degree of multi-programming, means it decides how many process will be moved from new to ready state, and then after ready to run state, short-term scheduler decides which process will be moved from ready to run state or from run to ready state. And finally the last scheduler, which is medium-term scheduler. Medium-term scheduler decides which process will be present in main memory and which process will be present in secondary memory. Medium-term scheduler is abbreviated as MTS. So generally wait or block state to suspend wait or suspend block state, or ready state to suspend ready state is handled by medium-term scheduler, because you know ready state is present in main memory while suspend ready is present in secondary memory. So whether a process is present in the ready state or not is decided by the medium-term scheduler. If there are no space available in the memory for ready state, then definitely medium-term scheduler will pick the process and it will give it to the suspend ready state. Okay. Similarly, if there are no space available for the wait or block state in the main memory, then definitely medium-term scheduler will pick the process and give it to the suspend wait or suspend block state. Okay. So long-term scheduler decides the degree of multi-programming. Short-term scheduler basically doing the context switching or moving the process from one ready state to run state or run to ready state. And medium-term scheduler basically swapping the process. Swapping the process means it moves the process from main memory to secondary memory and from secondary memory to main memory. So these points are worth noting that LTS responsible for context switching, LTS responsible for degree of multi-program, LTS responsible for performance or degree of multi-programming, STS responsible for context switching, and MTS responsible for swapping of process. Okay, so note this point because many times questions are directly asked from this scheduler topic. Okay, so in the next video we will see the operations which are performed on processes.